the name itself has two words, inverse trigonometry. We must have came across these two words. Is it? Inverse. We studied in where? Inverse of something. Functions. Trigonometry. We have studied previously. In that we are going to write exam in it. Okay. So trigonometric functions are there. For the trigonometric function, we are going to define inverse function. What's wrong in it? First of all, what is function? What is function? Function is a relation. Function is a relation in which all the elements of the domain is related with a unique distinct element in the codomain. Okay. Sorry, the unique element in codomain. Okay, that is what we call it as the function. So we have a relation that is from A to B, whereas all these elements should be mapped. Okay. Here some of them may not be mapped, not a problem, but here all these should be mapped. That's two with the unique element. Even this like two elements mapped with two elements mapped with the same image means not a problem. This like we may have, that is not a problem. How we can recall this is schools, that is boys. This is boys, that is schools. Here all the boys should go to school. Okay. Two persons can go to one school, but one person should not go to two schools. Okay. So in this diagram, this like one function is defined. This person is going to two schools. Is it fair? No, it is not. So this is simply a relation, not a function. Okay. And in the other one, see what means this? Two boys going to one school. Is this fair? Okay. Then it is a function. Okay. So in that we have that several types of function. Two major types only we will discuss. Injective and surjective function. Injective means what? That is one-to-one function. One-to-one meaning what? All the element should be mapped with a unique distinct element. This like two persons going to same school and all, no. Each one should go to one school. Okay, that is what? One-to-one. So in the terminologies we will see all the pre-image should have a unique and distinct images. Okay, image, pre-image, you know this terminologies, right? And then surjective means what? Onto. Here already all the persons are mapped. Domain, not a problem. But in codomain, if all the elements has a pre-image, all images are having pre-image. Simply, if the range has become codomain or codomain becomes range, then we call that as onto function. Okay. So in that, this kind of things and all allowed, not a problem. Two persons can go to one school, but the thing is, all the schools should have students. That is it. Okay, that is what? One-to-one and onto functions. In that, if the function is both injective and surjective, we call that function as bijective function. Remember, both one-to-one and onto, then we call that function as bijective function. Okay. Now, in the bijective function, what happens in the bijective function? Looks like nobody is noting down anything. See, in the bijective function, here all the elements are mapped with the unique elements. Here also all elements are mapped. So it is like simply one-to-one correspondence should be there. Onto everything has been mapped. So here everything distinct and unique. Okay. Now the definition of this function is f defined from A to B. And if we are defining the function, some other function from B to A, is it possible to define a function from B to A? That is also again a set. From here to there we can define. Since here all the elements are mapped, everything is images of a pre-image. Okay, then this function do exist. This can be a function. Then how do we call it? This G is a inverse of x, f inverse of x. So that is how we call the inverse function. So to have an inverse, a function should be bijective. Okay. Okay. Say yes or no, open your mouth and answer. Okay. If inverse exists for a function, we call that function as invertible. How do we call it? Yes, invertible. Okay. So, to become inverse exist, these are all things should be happened. Okay. This is what all about inverse function. Okay. Let me recall once again. Function, you know what is that? So, all the elements should be mapped. There some of them may not be mapped, not a problem. That is a function. And then one-to-one function means each element has been mapped to the unique element of B. Okay. Still in that case also here nothing can be mapped. Something cannot be mapped. Likewise it is be there. Not a problem. But the thing is here everything should be mapped to a unique element. That is one-to-one. On-to means here everything should be mapped. Codomain. So if both exist means we call that is bijective. So this like will be having the function. In that point bijective function, using a bijective function, we are defining the function from codomain to the domain. That is the inverse of the previous function A to B. Okay. Got it? Now come back to this trigonometry. So inverse for this one word alone, this much I explained. Now trigonometry. Trigonometry we have what? We have sin theta, cos theta, and then tan theta, cot theta, secant theta, cosecant theta. And we do have values for each of this. All of them are functions. Okay. Let us discuss sin theta first. Let me take it as sin x. Oh no, sin theta let it be. This sin theta is a function or not? How will you discuss? What is domain of sin theta? Domain of sin theta. Domain is a real number. And the range of sin theta, it varies from -1 to +1. Okay. Listen closely. Here I mentioned real numbers. That doesn't mean that everything is a number. Here in the number line, in between 0 we can mark. Okay. Each unit we can take unit. So that kind of unit, what I am taking is pi units I am taking in the real number line. Got it? So here pi, here 2 pi, here -5, here -2 pi. Okay. Now from here we are applying the values. So the other one exists. See, this is the domain, man. This is very important. This is domain of the function. Real numbers, x-axis. Okay. And the codomain value. That is why we are naming it as y is equal to f of x all the time. Okay. So that is the y-axis value. Here all the things are numbers only. Now tell me what is the value of sin 0. I am going to draw the graph of sin x. Sorry, sin theta. Sin 0 degree is what? 0. See, as I told you earlier, this is sin theta is equals y, or sin x is equals y. So here theta comma y, that ordered per you have to mark. So 0 comma 0 you can mark. And then in between 0 and pi, we have pi by 2, don't we? Are we having or not? Answer something, man. Say something. Simply keeping your hand in the cheek. Oh, what happened? This and all. Who asked this? That like you are sitting. Then what happened? If you are not going, if you don't want to continue this means you can continue tomorrow. No problem. Not a problem. Just tell me. Because you may have you may be thinking about that OT examination. You may have OT examination. What we can do? I think we are discussing those points as well. Is it? Does this help? We have domain and range for the functions. Is it? This one-to-one, on-to, bijective, everything. Okay. Still, I didn't step into inverse trigonometry. What is there for the OT exam only? I am revising. Think like that. Okay. Now, shall we draw the graph or drop the class? What we can do? Answer. Anything is okay for me, sir. Shravan. Let us draw the graph. 0, 0 we have to mark. This is 0, 0. Okay. And then pi by 2. When theta equals pi by 2, what is our value? What value we make it? 1. Okay. So here there will be 1. Here minus 1. So here I am marking that point. This point is pi by 2, 1. Okay. And sin pi value, man. Zero. See, here there is one formula we have. The value of sin n pi is 0 for whatever the n value you take. Sin pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. Everything is 0. Okay, where n is an integer. So here again we have pi, 0. Okay. Then here we have 3 pi by 2, isn't it? After pi, what will come? It is 3 pi by 2. What is sin 3 pi by 2 value? You know how to calculate? Sin 3 pi by 2, man. How we can calculate? Come on. Sin of. See here, this is improper fraction. 3 pi by 2. So we can write that pi plus pi by 2. Shall we? Then sin of pi plus theta. Remember, what is it? Sin pi plus theta, it is cos theta, is it? Minus cos theta. Good. Sin of pi plus theta. Come on. Sin of pi plus theta. Tomorrow you are having OT exam. You don't even know what is sin pi plus theta. Nice. Good. Appreciable. Answer someone. Come on. Yes, sir. There will be change or no change, sir, when pi plus theta comes. Minus sin theta. So, minus sin pi by 2. That is minus 1, right? So, this point is 3 pi by 2, minus 1. Likewise, this point 2 pi, as I told you earlier, that is 0 again. Let us connect all these points. This like we may have one graph. Is it? Likewise, here also. From 0, here minus pi by 2 will be there. For minus pi by 2, we may have minus 1. And then for minus pi again 0. Here minus 3 pi by 2. Likewise, it goes. So, that is how we have to understand the sine graph. Now, listen closely. This is our domain x-axis. All the values do have images. Is it or not? Is that a unique image? Is this a 1-1 function? How will you check whether this function is 1, 1 or not? See, that is why I explained. 1, 1 means 2 persons going to same school also should not be. Any 2 persons going to same school here? See, minus 3 pi by 2 goes to minus 1. Minus pi by 2 also goes to minus 1. Okay, this is domain, man. Same value. So here also same value. Is it? Now is this 1, 1 function? No, it is not. So okay, this is like I can't understand how I can check whether it is 1, 1 or not. Any other ways? There is a way. We'll keep one test. Shall we? We'll keep a test and we'll find whether it is a 1, 1 function or not. What is that test? It is called horizontal line test. What is it? Horizontal line test. If we draw a horizontal line, if that intersects more than one point, the function is not 1, 1. Okay. Take for example mod x. Mod x r. Let it be quadratic function, parabola. Whether this is 1, 1 or not? Not 1, 1. Okay. Horizontal line test. 2 points. Okay. Y is equal to x. That function you take whether it is 1, 1 or not. This like we may have the graph. If you draw a horizontal line, how much point it is intersecting? Only 1 point. That is 1, 1 function. Easy. Using the graph, you can easily find whether it is 1, 1 or not. Now here this function is not even 1, 1. So 1, 1 is not there means, will it be a bijective function? Okay. If bijective is not there, do inverse exist for this function? Then all these are pointless. Inverse trigonometry. Wrong chapter. Shall we? See, I only told you to have inverse function, to become invertible, a function should be 1, 1, onto and bijective. Is it or not? Look at this guy. He is just a function. He is not even 1, 1. Not onto as well. Onto means what? Codomain, all the values should be mapped, right? Who is our codomain here? Come on in the graph. Who is the codomain? If x-axis is the domain, who is codomain? Y-axis. Why man, that's not sadness. Here all the values has been mapped or only between minus 1 and 1 is mapped? This point 2 not even have a free image. So it is not onto as well. So it's really pointless to study inverse trigonometry. Then we'll move on to the next chapter. Okay. Shall we? Suppose if something is not good, what we can do? You really want that something is not good. Something is stopping you from achieving it. What we can do? Better leave it and we'll take the other chapter. You want an iPhone, but you have only less money. You do really want it by this weekend, so that in this weekend your friend birthday party is here. You can show off. What we can do? Whatever the adjustments we can do, we can do. Is it? We'll borrow from someone. We'll put EMI. That thing. This. We'll do some makeups, right? That is what we're going to do it here. This guy is not even a function, not even 1, 1, not even onto, but we want inverse function. So what I'm going to do is, I'm angry at this guy, so we'll take a long big knife, we'll chop this into pieces. Shall we? How? See, this big function may not be bijective, but one certain piece What piece it is? One piece. Which piece? Not that one piece, this one piece. Huh? See, this piece let me take. Okay, let us draw this separately. This is x dash, x, this is y, y dash. Okay, now in this, here it is restricted to these points only. What is it? Minus pi by 2 to plus pi by 2. And our function is only this piece exists, this s kind of function, s kind of thing. Okay, got it? But still our range is what? Here plus 1, here minus 1. Okay, so here the restricted domain, how do we call it? Instead of taking full real numbers as a domain, I am defining the function sin theta from the restricted domain negative pi by 2 to pi by 2, both included, to where it is defined negative 1 to 1. It is not real numbers. Okay, get to know the difference. Here this function sin theta is defined from real numbers to real numbers. Okay, here domain is real number, range is this one. Now I am cutting this real number into only that particular interval, again this real number into another particular interval, so that here all the elements will be mapped, is it or not? All the elements as images. Also I restricted this as a codomain. Look at the range. What is our range of this function? Negative 1 to positive 1. That is equals to codomain, is it or not? When range becomes codomain, what it will give? 1 to 1 now. On to, yes. See, this guy has become on to. Come on, successful. Way to go. And here, all the elements should be mapped to the unique element, right? We'll do the horizontal test right now, whether this guy passes or not. Horizontal test. How much point it is intersecting? Only one. Is this 1 to 1? So it is 1 to 1 and on to. Then what kind of function it is? Bijective. Okay. See, we turned one useless guy into useful one. Is it? Now my question is it possible to change this domain? Instead of taking this piece, is it possible to take the other piece, that is pi by 2 to 3 pi by 2? Possible or not? The only difference is we may have the domain alone changed, that's all. Still that guy is bijective or not? That is pi by 2 to 3 pi by 2. Take this piece alone. Are we having the same piece? Oh sorry, this lake. This lake, yes, we are having. In this, they look at this piece alone, man. So still this becomes 1 to 1 on to bijective. The same thing other piece also. Here whatever the pieces, minus pi by 2 to minus 3 pi by 2 to minus pi by 2. So we may have a bijective sine function. So among that, which is main, which is important, from where we have started, that is called as principal domain. That is called as principal domain. Okay, so this is our principal domain. Got it? And the values, those who come for principal domain, are called as principal value. Okay, so far what we have done? Only we turned this useless function into bijective one. Why we have turned this into bijective one? So that we can get the inverse. Inverse function means what? Come on, the definition. See, let it be sine inverse of x. From where to where it will be defined? Good. Is that thrown or fell down? Looks like it's been thrown. What, man? Front of you. But I see that one invisible creature behind the mirror. Behind you there is a mirror, right? In that mirror some face is showing at some time. It already became late night. Be careful. I am speaking to the creature, not to you. Okay, shall we? Come on, man, inverse function. Sin theta defined from this interval to this interval. Then inverse function will be defined from where to where? Yes, that is it. Way to go. So, it is defined from the domain of the sine inverse function is -1 to +1 to minus pi by 2 to pi by 2. Okay, got it? On the graph of that sine inverse, how does it look? See, I told you horizontal is our domain. Suppose we turn this diagram, we make this y as horizontal. That is our inverse function graph. Okay, let us draw. See, this is still y axis, this is still x axis, but here the values alone changes. Here -1, here +1, and then here pi by 2, here minus pi by 2. What change you found? This has been plotted into the x axis, and this minus pi by 2 plus pi by 2 has been plotted into y axis. Now look at this graph. How this graph will come? Come on, man. Is it the same graph? Then come on. See, you will see this sine inverse of pi by 2. So pi by 2 comma 1. See, sine inverse of pi by 2. How will you calculate sine inverse of pi by 2? Oh, sorry. Domain, man. My bad. 1. Sine inverse of 1. This value has to be involved. Okay. For what value of theta 1 will get in sine? Pi by 2. Okay. So the point is 1 comma pi by 2. Where is that point 1 comma pi by 2? Here. Okay. So from here to 0 it will come. Here to 0 it will come. And from 0 to here negative pi by 2. This point is -1 comma negative pi by 2. Here 1 comma pi by 2. Got it? That is the graph. Do you see any difference between this and that? Don't say both are same. Any difference? Okay. That is it. That is the whole mechanism of the inverse function. Also, some things has to be noted. See, you understood how an inverse function has been built, right? Okay. Now, let me put everything in a nutshell. Shall I erase everything? I think all these details is available in the book itself. Is it? Are you noting this down? No, I don't think so. Are you noting this down? No. Good. Nice. See, you all are bookworms. Just follow the books, not a problem. Also, I am seeing some couch potatoes. Okay, that was a inverse function. See, what I was going to tell? Tell me, man, what I was going to do? Not couch potato, the other thing. See, previously we have got used to this. Sin pi by 2 is equals 1. Sin pi by 6 equals how much, man? 1 by 2. Sin pi by 3 equals root 3 by 2. So here substituted value is theta, angle. Answer we got is a number. Okay. On the other hand, sin inverse of 1, substituted value is a number. So answer is theta, angle. What angle will get the value of 1? It's pi by 2. That is the simple difference between these. Okay. And then now tell me cos inverse of root 3 by 2. Pi by 6 or 3, man. Pi by 6 means 30 degree only will get, is it or not? Pi by 6 means 30 degree da. Pi by 3 means 60 degree. Okay. So that is it. Everything. Got it? I think you have got one understanding about how inverse function works. Okay. Let us discuss cos function. Yeah, shall we? Shall we? Okay. What was our first step? We have to define a cos function. We have to understand how that graph will looks like. I think none of you opened your book, I think. Open. Yeah, okay, good. See, first let us draw the graph of cos. How to draw the graph? Come on, anybody? See, this is y. We have to mark that known value. Each unit we should take it as pi units. Okay, minus pi, minus 2 pi, everything. And then cos 0. Cos 0 degree, how much? Oh, not cos 0 degree, cos 0. This is 0. Okay. And cos pi by 3. 1 by 2. Okay. So let us mark. See here I marked minus 1 plus 1. Nobody noticed. Yes. Simply I am checking whether you are paying attention or not. Cos 0, 0. Then cos pi by 3, 1 by 2. This one is correct here, the other one, previous one. Cos 0 is how much? 1. Good. So the point we have to mark in the graph is 0, 1. Where is that point 0, 1? 0, 1. Okay. And these values, man. Cos pi by 2. 0. See, also you have to know that cos of 2n plus 1 pi by 2, that means odd multiples of pi by 2 are 0. Okay, where n is a integer. And also we have cos n pi is equals minus 1 power n. Okay, these two are important formulas. Note this down. Okay. Now tell me cos pi by 2 0, then that point is what? 0 comma pi by 2 or pi by 2 comma 0? Yes, substituted value comma the other one. Okay, pi by 2 comma 0. Okay, and then cos pi value, man. So this formula, n pi is minus 1 power n, then cos pi minus 1. So this value is minus 1 comma pi, is it? Pi comma minus 1. Okay, so this is like the graph flows. Okay, and again, come on, where it goes? When it will go again to 0? Guess what? For pi by 2 it becomes 0. Then in between pi and 2 pi, what value will be there? Huh? 3 pi by 2, yes. For 3 pi by 2, this guy will reach again 0. And then to 1, when this guy will reach? Two pi. Okay, so that like this graph is flowing. Here also minus pi 0, and then minus 3 pi by 2 we have, sorry man, here minus pi by 2 it is 1. No, I'm just bluffing. See, it is not minus pi by 2. Here minus pi. For minus pi by 2, this guy again will become 0. For this minus pi, again this will become minus 1. And then 3 pi by 2, 0, that like this going. It is not that simply putting like this, this is the graph of cos, no. Okay, it has a meaning. But it looks same like sine function. Is it? Does this look like same function, same as sine function or not? Same only. But the only difference is where it starts. So values are different. See the sine function, this like it will go. Okay, both are different. Got it? Now for this guy, we are going to make this function as bijective one. Check whether this guy is bijective, 1 to 1, non to anything. Is this 1 to 1, on to, bijective, anything? How will you check 1 to 1, man? All x-axes are mapped or not? Yes. Horizontal test. It is not 1 1. Horizontal line if you draw means it is intersecting more than one point. Onto is this? No. So we have to restrict this guy's domain. How we can restrict? Come on, guess what? Any ideas? Yes, restricted domain. From where to where it can be defined? See, previously we had this like one function, right? That like one piece involving positive. Again one piece coming. Involving positive, both negative, positive and negative. So that like one piece you just check. That should start from the first quadrant. So this piece we can take from 0 to pi. What is it? 0 to pi. From that interval to where we can define? Is that fully the real number or only to the range? What is range of the cos function? Minus 1 to plus 1. That is it. That is the restricted domain function, and the graph of that follows like this. 0 here, pi here, this like the graph will come. Okay, got it? Any doubts? That is what the question I am going to ask next. See, this is the restricted domain of the function cos. To make this bijective, cos inverse. What is the domain of cos inverse of x? Minus 1 comma 1 to 0 to pi. Okay, got it? Okay, so this is how we can understand this inverse function. Still tan function is there, sec function is there, cosec function is there. Everything flows with the same idea. Okay, so also while working with inverse function, some points has to be noted that, see, sine inverse of x, if I mention this, is that means 1 by sin x? We used to write this, right? No, it is not. It doesn't mean like that. That is the separate notation. Okay. Also, we are habituated to this. Sin square theta is equal sin theta whole square, right? Now, shall we write like sin inverse of theta is equal, sin inverse of x, let it be, is equal sin x whole power minus 1? No, it is not having, it is not meaningful. Okay. So these kind of things we should not do. Clear? And you know what is principal value, principal domain, right? That is it. Any doubts? Clarification. Okay, come back to the packages.